Take 4. This is our multimeter.
500 millivolts.
Yeah, Kylo's gonna crank this.
Yeah.
Oh, it's already at 500 millivolts. Okay, then you see here, it's at our DC voltage reading about just about that.
500
And then as Kylie cranks this bad boy,
to
you'll see,
1.5.
you'll see the DC bar graph raise and the RMS stays solid as ever because it's not AC.
Oh, 1.5. Here we come.
Okay, then we go to 1.5. Approaching.
Boom. 1.5.
Easy.
Boom.
1.5 volt offset.
Okay.
And
Now, changing this. Frequency 500 hertz.
okay, so now we're gonna have a 500 hertz sine wave with 1.5 volt DC offset.
Amplitude is
Okay.
3. Hold on, I gotta change. Amplitude and peak to peak is 3.
Okay,
Alright.
okay. And we got a 1.5 volt DC offset approximately. Frequency you can see is 500 hertz. Peak to peak voltage is a little off, 2.4 when it should be 3, but if you look on the oscilloscope, you see that's just a property of the function generator. For whatever reason, it's the change in the Y, we're measuring the cursors there is 2.4 volts. Okay, so now we're going to do a 1 volt peak to peak sine wave with a half volt DC offset at 100 kilohertz.
Point 5. Alright.
Okay, and you can see 0.5 volt DC offset.
1
And
kilohertz.
oh yeah, we have to change the frequency.
To 1 kilohertz.
Okay,
There we go.
then you can see 1 kilohertz right there. And what else is the requirement? Oh yeah, the peak to peak voltage, which is again a little off due to whatever's happening with the function generator voltage here. But you can see it's 0.8. So there we go.
Alright.
And now we're going to do a 1 volt peak to peak sine wave with 2.5 volt DC offset at 1 kilohertz. So it should have the same specs, just with a DC offset of 2.5. And there it is. 2.5. Nearabouts. The peak voltage. Again, a little off, but proportionally off, I suppose. Okay, next is 3 volt peak to peak sine wave.
Triangle.
Oh, we need a triangle. Okay.
.50 hertz. Cause yeah. 1.5. And
3 volt peak to peak.
so, as you can see,
RMS is going up. So it starts to get a little funky at lower frequencies. You can see this
yeah,
our frequency measurement there is
the highest we can get is around 100 or so.
so voltage measurements start to go off there a little bit, but
Everything else is
Gucci. Okay. And next is 1 volt peak to peak square wave with 1.5 volt DC offset at 10 hertz. And this will be absolutely bananas.
.10 hertz, very, very small. Like I said, we can get pretty close, but not necessarily less than 100 or so.
Okay. The next one is 3 volt peak to peak sine wave with 1.5 volt DC offset and the highest possible frequency. Highest possible frequency. Oh, well, we already showed that with our 1 kilohertz actually. I guess we can increase the peak to peak voltage of the sine wave. So
Okay. 1.3. Offset is 1.5. Then our hertz must be, what was it, Ryan?
1 kilohertz. Then we'll go up from there to show the max frequency. So, all right, so this is 1 kilohertz. Then if we increase it to, say, 2,000 kilohertz, you see it tracks pretty good. If you go to 3,000, still tracks well.
Pretty good.
If you go 4,000,
It's pretty good.
so off by a few hertz, 3, 5, something like that. Then by 5 hertz,
Still pretty good.
6 hertz,
Still pretty good.
7 hertz,
Still pretty good.
or wait, this is kilohertz, my bad.
8 kilohertz.
Okay, 8 kilohertz, 9 kilohertz. Then you can see it starts to have some
Slight fluctuations now.
fluctuations around
Around 10.
max out to 10
Yeah.
kilohertz.
So that's that. And then our next part, square wave. Right, Ryan?
Yep.
Yep. And lowest possible frequency.
Probably about 200 or so.
Yeah. 200 or so. So right now we can go around, what is it, Ryan?
All right, so 200 hertz is around here. You can see it's pretty good with that. But then you start to decrease. Any lower than 200 hertz.
And so if you go down to 1 hertz, which is very, 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 very small, we get,
Basically unusable measurements.
yeah.
Thank you.